All right, hello. What we're going to be doing is we're going to be looking at a few concepts in section P.1, which is about algebraic expressions in real numbers. So some of the things that I want to touch base with on is evaluating and simplifying algebraic expressions, looking at some inequality symbols, as well as looking at some mathematical models. One of the most important things when evaluating is understanding how to use order of operations. What I would like you to do when you are working through several of these example problems by yourself, I want you to do it without a calculator. And so practicing order of operations is very important. So we want to do parentheses first, followed by exponents. Multiplication and division is third, but remember, always work from the left to the right. So even if we see both of those things, you're not always doing multiplication first. It just depends on what's farthest on the left. Same idea then with our fourth one, which is addition and subtraction. So let's take a look at this example problem. I want us to evaluate 9 minus 2 times the quantity x plus 11 squared. But I want it when x equals -3. So evaluating means they're giving us the value for that variable. We're going to substitute that in. And now we're going to follow order of operations. So order of operations, we start with our parentheses. We are going to want to add -3 plus 11 gives us 8. Next is to do our exponent. So I want to square 8, which gives us 64. Next would then be multiplication. 2 times 64 gives us 128. And then finally, our last step here would be to subtract, and we end up getting a -119. We can also use evaluating when we're looking at some mathematical models. So notice that mathematical models are really just going to be some real world application type problems. Here I'm giving us an example where I want us to convert from Fahrenheit into Celsius. So since they're giving us 86 degrees Fahrenheit, we are going to substitute that 86 in for F and start solving for C. So once again, we have to follow order of operations. I have to do what's in the parentheses first. So by subtracting those two numbers, that is going to give us 54. Then I'm going to go ahead now and do my multiplication. When I multiply that fraction by 54, we end up getting 30. So we end up with a 30 degrees Celsius for our answer. Another type of application problem here deals with not only a model with a formula, but it also gives us then a bar graph, and it's wanting us to compare. So it's giving us this formula. It says that this formula models gray wolf population P, and X represents the years after 1960. So the first thing they want us to do is to find the population in 1990. So that means that we are going to actually know what our value of X is. X represents years. They are telling us that the model is from 1960. We want to know what it is in 1990. That's a 30-year difference. So we're going to substitute 30 in for X, and that will give us our population. So obviously, this type of problem, I would be okay with you using a calculator because we're dealing with decimals. And so this one, I would say if you have a problem like this on your homework, definitely use your calculator. So plugging all that in and simplifying, we end up with a population of 1,713. So then it's asking how well does the formula model the actual data shown in the bar graph. So we go over to the year that they're asking for, which is 1990. Notice that the bar graph is telling us we have 1,700 for our gray wolf population. And since our answer was 1,713, I would say that it is pretty accurate graph or representation. All right. I wanted to just quickly review the inequality symbols. This is something that we're definitely going to be using a lot in chapter 1. So we've got the greater than symbol, less than, greater than or equal, or less than or equal to. So just kind of get familiar with those again if you have forgotten them. Another thing that we're going to be talking about is absolute value. So just remember, absolute value is basically what is the distance something is from 0 on a number line. So obviously distance represents a positive value. There's really no such thing as a negative distance. So notice that by our formal definition, if x is greater than or equal to 0, that means that we're dealing with 0 and positive numbers. So looking at the example, 11 is a positive number. Plugging 11 into the absolute value will then give me 11. It's going to stay that exact number. Notice that the second part of the definition says that if x is less than 0, meaning it's a negative number. What happens when we have a negative number is when we plug that negative number into our absolute value, we actually want to take the opposite of that number. So notice that negative 4 is less than 0. Plug negative 4 into the absolute value, you're taking the opposite of that negative, which gives us a positive 4. So it's pretty clear for us to see when we have just a single value that our answer is going to be the positive of that number. But some of the examples that you're going to be looking at is you're going to be asked to rewrite without the absolute value bars, and you're giving multiple numbers within that absolute value. Here's the thing. I don't want you to use a calculator. I'm not looking for an actual number. I'm looking for you to take that expression inside and just give me what it is without the absolute value. So if I focus on the fact that this number isn't something that I'm just going to know off the top of my head, we can kind of estimate what this is. Notice that the square root of 5 is going to fall in between the square root of 4, which is 2, and the square root of 9, which is 3. So this number is going to be something that's approximately in between 2 and 3. Okay? So approximately 2 to 3. So obviously then, if I'm taking 9 minus that number, this whole entire expression here is going to be a positive number. And so because that's going to be a positive number, all I have to do is really just drop the absolute value bars, and that will stay my final answer. When I look at this next example, this pi is approximately 3.14. Notice that that then is going to be 7 subtracted from it, which would give me then a negative number. So remember, our definition is that in order to drop the absolute value bars, we actually want to take the opposite of what that number is. So I want to take the opposite of that entire expression. Well, that means that I'm going to have to distribute that negative. So really, my final answer is going to be changing the signs of both of those numbers. It now becomes a negative pi plus 7. Remember, when we're simplifying, it says an algebraic expression is simplified when the parentheses have been removed and like terms have been combined. So let's just look at one example. Remember, parentheses can be both curved as well as those brackets. Okay, so we've got two different sets of parentheses here. So notice that order of operations, we focus on parentheses first. Notice that within the brackets, I have my parentheses of 4x minus 2. Well, those are not like terms, so I can't really do anything there, which means that I'm going to distribute that negative. So we're going to have a negative 4x and a positive 2. Now I'm down to one set of parentheses. I'm going to go ahead now and combine any like terms that I have within this set of parentheses. So 1 and 2 is going to combine into 3. Now that I've taken care of the parenthesis within the parenthesis, following the rest of my order of operations, since those are not like terms in the parentheses, I'm going to once again do multiplication next because there are no exponents. Distributing that 7 gives me a 21 there, gives me a negative 28x. And then finally, notice that my last step is to combine any like terms. We've got a negative 3x as well as a positive 3x and a negative 28x. So that's going to give us a negative 25x. So 21 minus 25x would then be my final simplified answer. So those are really the things that I wanted to hit.